Okay, this is 7.1, and these are a little shorter problems. So this is 12 through 16. Refers to this graph and tells you a particle moves along the x-axis, units in centimeters. Its initial position at t sub 0 seconds is x sub 0. The figure shows the graph of the particle's velocity. The numbers are areas under the region, or the closed region. And number 12, okay, what's the particle displacement between t equals 0 and t equals c? That's number 12. So the displacement, this is going to be, this is the velocity, so the actual displacement is just the area. So this is going to be negative 4 plus 5, negative 24. Negative 4 plus 5, because I'm on top and I'm below, negative 24. Oops. Okay, and so my displacement is going to be equal to negative 23 centimeters. Okay. Is that all right? So that's actually how much I've moved. And again, that's in centimeters, yes. Okay, so that's not too bad. Number 13, what's the total distance traveled by the particle in the same time period? So the distance traveled. So we're going to go to the left 4, to the right 5, to the left 24. So we just take the absolute value. So that would be just positive 4 plus 5 plus 24. So we're taking the absolute value of those distances. Because whether I'm going left or right, it doesn't matter. That's distance traveled. So that ends up equaling 33 centimeters. Okay, the next one, number 14. Approximately where does a particle achieve its greatest, number 14, give the position of the particle at times A, B, and C. Now the position. Now remember we started at x sub 0, so x sub 0 equals 15, so that's our initial position. So at A, I started at 15 and then I go to the left 4, so that's going to be 15. A will be, I better put it over here, 14A. A will be 15 minus 4, so that will equal 11. So that's my position, 11 centimeters. B, that will be 15, and to the left 4, but to the right 5. So that means I end up at 16. And I guess that'd be centimeters from the initial point, or centimeters from wherever the 0 point was, or to the right, I guess. And letter C, 15, to the left 4, to the right 5, and to the left 24. That ends up being negative 8. So I'd be 8 points to the left of wherever the beginning point of this whole situation is. All right, well, I guess they're negative 8 relative to my 0 point on my line, not my 0 point on my time. Okay. And then number 15, approximately where does a particle achieve its greatest positive acceleration on the interval from 0 to b? So from 0 to b, where's the greatest acceleration? Now, what's the acceleration? The acceleration is actually the derivative of the velocity. Now, the derivative of the velocity is the slope. So here the slope is negative. Here the slope is 0. And here it's getting more and more positive. And then it's 0 again. And then it starts to be negative. So it looks like the greatest acceleration is today. And then on the whole interval, number 16, approximately where does a particle achieve its greatest positive acceleration on the interval from 0 to b? Well, again, this acceleration is negative. It's 0 there, and it's positive, and it looks like it's the most positive there at c. So remember, we're just looking at the slopes of the curve. Okay? And then the rest of them aren't too bad either. So if we look over here, these I kind of drew these sketches, so I hope you can see them. So number 17, what they want you to do, two things. A, find the particle, remember x sub 0, I'm sorry, t x sub equals 2. So we know that x equals 2, pardon me, when t equals 0. Okay, so that's my position. Oh, I wrote x equals 2. Said one thing, wrote the other thing down, so excuse me. All right, x equals 2 when t equals 0. So find where the particle is at the end of the trip, and then find the total distance traveled by the particle. Well, the particle at the end of the trip, A, it's going to start x equals 2, plus however much we've covered. Well, remember this is the velocity, so the actual area that I covered, or the actual distance that I covered, is just the area under the velocity curve. So I've got all these triangles. Now the base is 1 and the height is 2, so the area of each of these triangles is 1. So that actually represents the distance I've traveled, so that would be okay. So where is the particle at the end of the trip? Well, this is my s sub 0 plus my delta s. So that's, I end up 6 units. Okay, and letter B, find the total distance traveled by the particle, B. Well, that's just going to be this distance plus that plus that plus that, so that's just going to be 4. Okay, on number 18, A. Again, we're going to start at 2. That's going to be my s sub 0. And this area is plus 1. It's a 1 by 1 rectangle. This is negative 1. That's plus 1. That's negative 1. So those are going to cancel each other out. So actually, I'm not going much. In other words, I go to the right one, then I go to the left one, then I go to the right one, I go to the left one. So I end up right back at 0. So my position is 2. That's where I end up at the end of the trip. Basically where I started, which was x equals 2, and then letter B. How far did I travel? Well, this is the s plus the delta s. So the delta is how far I traveled, so that was 0. Oh, pardon me. Not the delta s, because it's the absolute value. So this is 1, this is negative 1, that's 1, that's negative 1. But that ends up being 1 plus the absolute value of negative 1, plus 1 plus the absolute value of negative 1, which is just 4, pardon me. So we went right 1, left 1, right 1, left 1, so we end up going 4. Okay? Now we got some more interesting geometric figures here in number 19 and 20. So again, find where the particle is at the end of the trip. So remember again, my s sub 0 is equal to 2. And now we have to find, our net distance traveled. Well, again, this is a triangle, but its area is 1, but it's below, so that's going to be negative 1. Now over here I have a trapezoid. Remember the area of the trapezoid equals height, and my height here is going to be 2 times 1/2 base 1 plus base 2, and my base 1 and my base 2, this is going to be 1 base 1, these are the parallel sides, 1, 2, 3, 4, all right, plus this base, which is just from 2 to 3, 1, so that's going to be 5. So this will be positive 5. And then this triangle here, this is a 2 by 1, so this is going to be 1/2 2, which is another negative 1. Okay, so my distance here, this will be my delta S. I'm going to the left 1, to the right 5, to the left 1. So that's going to be negative 1 plus 5 minus 1 Now that's going to end up 3. So 2 plus 3, that will be my delta S. That'll be my actual displacement. So it's going to be 5. That'll be my position. Okay, and then the letter B. How far did it travel? Well, we take the absolute value, so that's just going to be, I went to the left 1, to the right 5, to the left 1, so I actually went 7, so I could say the absolute value of -1 plus the absolute value of 5 plus the absolute value of -1, so I end up going 7. So I traveled 7. Okay? And if you look at that, you could say that that's going to be, they're going to go from 0 to 7 of the absolute value of v as a function of t dt, if we remember our formula. And that was equal to 7. Okay? And the last one, number 20, we have this sketch here. And again, we got triangles, trapezoids, and triangles. And again, my S sub 0 is 2, so it's going to be S sub 0 plus delta S. So I have to figure out how far I end up going net-wise. And this is a triangle. Now this is 3 by 2. So 3 times 2 is 6. So that's going to be 1/2 6 is 3. So the area of this triangle is 3. I have another trapezoid down here. Again, the height is 3. So area that's trapezoid equals height 1/2 base 1 plus base 2. Now my base 1 will be 1, 2, 3. I'm going from 3 to 6. And my base 2 are 1, 2, 3, 4, 5. So that's going to be 3 times 4. So that's going to be 12. That's going to be -12. And this triangle, this height is going to be, 1/2 base times height. The height is 3, and the base is 3, so 3 times 3 is 9, so that's going to be 9/2 or 4.5. So if I add these up, I get 3 minus 12 plus 4.5. All right, so my delta S, so I'm actually, displacement's going to end up being -4.5. That ends up being 7.5 minus 12, which is -4.5. So I'm going to add this up here. That'll be my delta S. So my actually end position will be -2.5 centimeters to the left, I guess, of the 0 point on the line. And then if I want the actual distance traveled, I'm going to take the absolute value of all these. That's going to be the 3 plus the absolute value of -12 plus the absolute value of 4.5. And that ends up being 19.5. So that's actually how far I traveled. Okay, so that wraps that up. I hope that makes sense. And make sure you draw sketches and label them like this. It makes it a little bit easier for you, okay?